Hello everyone, welcome to the session on Anova. In this session, I'm going to explain about Anova, and I'm also going to demonstrate how to get the results of Anova analysis using Python and Excel. You basically will try and get the Anova table, right? So that's what we are going to see in this session, right? Let's understand Anova. Anova stands for analysis of variance. But what we are actually trying to assess is we are trying to compare the means. Okay. We are going to compare and contrast the means of different groups. For example, let's take a student example. Student studies and takes up different examinations like mathematics, physics, chemistry, right? These are the three subjects, let's say the student takes. What will the marks obtained in the three subjects, will it be the same? Will the average marks obtained by the students, will it be the same? Or we will consider one more scenario, that is physics, right? Let's take physics as a subject. Okay, this is taught to three groups of people, A, B, C. These are the three groups of people to whom physics is taught, right? This contains about 30 students, and B also contains about 30 students. Let's assume this also contains 30 students, right? Physics is taught to 90 students, 30, 30, and 30. Will the average mark obtained in the physics examination by students in group A, group B, and group C, will it be the same or will it be different? That is what will be answered by analysis of variance, right? So I have three groups. Let's call this as A, B, C. Okay. I try to answer the question whether the average of A, B, and C, will it be same or different by studying variance. You may ask this question, we are talking of studying of means, why are you using analysis of variance? When I say the word, I want to compare and contrast, am I not talking of difference? And difference is best understood by using variance, which is why for comparing the means, we are actually using variance, right? Please understand the H naught and HA, okay, which is nothing but null hypothesis and alternate hypothesis, will be what? The mean of A and mean of B and mean of C, this is mu, okay, the Greek letter mu, which denotes mean, right? Mean or arithmetic average, is the same in the three groups A, B, and C, right? We are talking of the physics example. You can consider, group of students for three different subjects also, right? Entirely up to you. I am taking the physics taught to three groups of students, right? Mu A equals mu B equals mu C. And what will be the alternate hypothesis? At least one of the means is different, right? At least one of the means is different. That is the alternate hypothesis. Please note this, right? So based on the F test or the P value, I will either accept or reject the null hypothesis. And what is this F test? Right? That is a term that is often used with ANOVA. Right? What is this F test? F test, computes the difference between the variance that exists among groups and also the variance that exists within groups, right? For example, here I am talking of variance that exists among groups, right? Here, variance that exists in A, variance that exists in B, variance that exists in C is represented. This is about among groups, not within groups. This is within, right? This is within. What you're seeing here is within and this is between. Okay. When you compare more than two, among is the right word, okay, but between is used widely, so I'm using between. Okay. Between is what is the difference between A and B, A and C? What is the difference between B and C? Right? So I'm comparing the means among different groups, right? Between different groups. That's what I'm doing here, right? So this is within and this is between. It is the same distribution, right? I'm talking of the same distribution for the A group, B group, and C group. Here I'm comparing between A and B. This is A and B, right? This is B and C. This is A and C, right? Whereas here I'm looking at variance only within A, within B, and within C. So when I analyze, when I look at the ratio of between variance and within variance, that is this variance and this variance, I get what is known as F value, okay, or F statistic. If the F statistic value is 0 or closer to 0, or is it some other value, that is what we are interested. If it is closer to 0, it means we have to accept the null hypothesis. The means are same or nearly the same, right? You can also use p-value. If the p-value is less than or equal to 0.05, right, we reject the null hypothesis, right? That can also be used. You can either use F statistic or the p-value, okay? You can use any one of this to either accept or reject the null hypothesis, okay? So please keep this in mind, right? So here in this example, I am considering only one factor, right? I am considering only what is known as one factor. This is known as one factor ANOVA. Shortly, I will show you two factor ANOVA, where I am considering two factors, right? Here I am considering only one factor, right? Somebody studied and somebody obtained marks. A teacher taught and some students obtained marks. So it's only one factor, right? So let's first demonstrate this one factor, right? I'm taking a set of four groups. While explaining the concept, I took three groups. Here I am taking four groups, four arrays I am considering. So for this, I'm going to programmatically demonstrate, how to compute the value, the F test and the value, right? So that's what we are going to see now. I'm using Google Colab, okay? So let's import NumPy, right, and pandas, because we are going to work on arrays. And this is the library that, rather this is the data set, sorry, not the library, the data set that I'm considering, okay, four groups. For one-way ANOVA, I am going to be using scipy.stats, this is the library. From this, I'm going to import f underscore one way, right? So once I do this, f underscore one way, I give a, b, c, d, and I have the result, right? Right? In this case, the p-value is greater than 0.05, which means I accept the null hypothesis. The average of A, B, C, and D are the same or nearly the same, right? You all understand? Now let's see the concept of two-way ANOVA, and we will programmatically do the two-way ANOVA analysis. In two-way ANOVA, we are going to consider two factors. In the earlier example that I discussed, we considered only one factor, right? The marks obtained. Here, what am I trying to do? I am trying to ascertain if administering vitamin C, will it result in increase of tooth? Okay, that's what I am ascertaining. So I have 10 people to whom I administer this vitamin C in different dosages, 0.5, 1 and 2 mg, through two delivery methods, orange juice and ascorbic acid. We all know that vitamin C is available in abundance in orange juice, right? It is available in ascorbic acid also, right? So I administer vitamin C through 2 delivery methods and 3 vitamin C dosage levels, right? So there are 10 subjects to whom this is administered. We have the resultant increase in tooth length that corresponds to the delivery method and also the dosage. So this is my data set. I am going to use this data set and ascertain if the increase in tooth length, is it the average increase in tooth length, is it the same across vitamin dosages and across delivery methods, right? That's what I'm going to ascertain, right? Using ANOVA, what do I ascertain? I ascertain the average, right? I check whether the average is the same across different dosages, different delivery methods. So my null hypothesis is there is no difference. My alternate hypothesis is there is difference, right? The way we construct the null and alternate is the same, in ANOVA, whether it is one factor or two factor, right? Do you understand? So I consider 10 subjects or 10 people to whom vitamin C is administered in different dosage levels and different delivery methods. So this is my data set. Okay, this is available in the form of Excel sheet, or CSV comma separated values file. Okay, so I am going to import this file and I am going to use a library and do a two-way ANOVA analysis using Python code. That's what I'm going to do, right? Do you understand the difference between one factor and two factor? So here I'm considering two factors. So length is this is my what? Dependent variable. This is my independent variable, right? So length is dependent on dosage and delivery methods. Null hypothesis is the average increase, which is what is denoted by len, right? The average increase. Okay, the average increase is dependent on the dosage and the delivery method, right? So null hypothesis is the average increase is the same across dosage and across delivery methods. Alternate hypothesis is at least one of the methods results in a different average. Okay, when it comes to increase in tooth length. Do you understand the two-factor ANOVA now? Right? Do you understand the data set? Let's go import the data set into Colab. Google Colab, is the development environment. Okay, and we will see the result now. Okay, the library that I will be using for this purpose is this library, PINGOUIN. Okay, you can't straight away do an import. You have to first do an installation. Okay, which is what I have done here. Pip install. Okay, and once this is completed in all aspects, you will get this message: successfully installed, right? So that is installed. See, understand the data set that I showed, right? That is available in the form of a CSV file that is available in my Google Drive, right? Because this is a cloud-based development environment, right? So I need to import this. For that, I first need to establish a connection between Colab and Google Drive. That I achieve through this. Once I run, it will ask you to provide access to Google Drive, right? Through this command, you are providing access for Colab, okay, in Google Drive. That's what is happening. You have to complete that. Just click OK, right? You will get this message. And through this, I am reading, okay, data, I am reading it. I am checking, what are the top records, the top 5 records. How does the data look? As it uploaded correctly? That is what I am doing here. Now I import this library as PG, okay. And after that, I do what? I do the analysis of variance, right? This is a multi-factor analysis of variance, not just two factor, okay? You can give additional factors also. So this gives, what is my dependent variable, right? So what are the factors? That's what you indicate in between. Data is what data? I have given the data frame, I have named the data frame as data, right? And here, I give, this is the place where the data frame is mentioned. And, I want a detailed one. not a, you can give detailed equal to false also, right? So you will have the ANOVA table. This is a detailed table, right? So what does the detailed table tell? It tells, this is factor 1, factor 2, and what is this? Factor 1 into factor 2. This studies the interaction effect. So when I have two factors, two factor can interact, right? You understand? Two factors can interact. So this is A, B, this is A into B. So I have the F value here, right? In this case, we are getting P value less than 0.05, which means I will reject the null hypothesis, right? And F scores are not closer to 0, right? So we reject the null hypothesis. How do I say that P value is less than 0.05? This says 2, right? You may get that doubt. Look at this, e to the power minus 4. That is, this is actually 0.0002. This is even less than that. This is 0.002. That is, it is less than 0.05. So I reject the null hypothesis, right? Which is, I reject the null hypothesis. That means all these things are having an impact. Even the interaction is having an impact. The average increase in length is not the same. That means this particular study, is effective. Vitamin C dosage and delivery method is having an impact on the desired outcome, which is the increase in tooth length. Right? Do you understand? Okay. So after this, we all will go and take vitamin C. It will increase the tooth length. Right? Okay. So that's what this particular study analyzed. Now, whatever I showed now, right? Whatever I showed now, the one factor and two factor, right? I demonstrated using Python. I'm going to demonstrate using Excel because some people are comfortable in Excel, some people are comfortable in Python, right? See, I actually come from the world of machine learning. I'm far more comfortable with Python because Python offers a lot of flexibility to me. That level of flexibility is not there, in Excel. But still, some people want to do analysis using Excel. So I will demonstrate that now. Okay. Now let's see one factor ANOVA, how to do that using Excel. So this is my data set, right? This is my data set that I used in Python programming, ANOVA also. Okay. So for this, we will be using data analysis pack. So data analysis tools, you need to import and install. It won't be readily available in Excel. Okay, so this is like an add-on that needs to be installed. I have already installed it. So let's apply this data analysis ANOVA single factor. Right, let's click OK. So I've selected, this is there. Labels in first row. This is my label, right? A, B, C, D groups, right? And where do I want the output? I want it in a new worksheet. You can also indicate, a particular cell, right? Or you can even choose new workbook. Let's click OK. Can you see this? We have the results now, right? The ANOVA table is there, P value and the F value. We saw the same P value there, right? We saw the same P value there. In this case, we will accept the null hypothesis because it is greater than 0.05, right? Now let's go and do two-factor ANOVA using Excel. Remember, for two-factor ANOVA, this is the data set that I introduced. But for the purpose of doing analysis using Excel, I need to construct the ANOVA data set like this. Type VCNOJ, dose 1, dose 2 and dose 3. That corresponds to 0.5, 1 and 2. Right? So these are the two delivery methods. Ascorbic acid and orange juice. Right? So these are the two methods in which the delivery has happened. So this is the data set I introduced. I have to construct the data set like this. for the purpose of doing Excel analysis, right? If you have to use Python, you have to have the data set in this format. If you're going to have data set in this format, it will not work for Python. Please note that. Okay. So this kind of formatting is needed for Anova using Excel. So let's go to data and we will click data analysis. Two-factor with replication. What is this without replication? Okay, we will see that very shortly. Okay. So let's do with replication. I click that. So what is the input range? So I have selected input range. Rows per sample, this is 10, right? I have to indicate. What is the alpha? This is the confidence level, right? Remember, p-value is less than 0.05, greater than 0.05. So this is the alpha. And where do I want the output? I want it in a new worksheet. So let's click OK, right? So I have the same set of values here as well, right? Let's see if I can you see this here? E to the power something is now become 0.002. All these, this is e to the power minus 18. That is, all these values are less than 0.05. Okay, which means I will reject the null hypothesis, right? Which means I'll reject the null hypothesis. So each of the factors are having an impact, including the interaction, right? Do you understand? And the p values, they correlate with the f values as well, right? None of the f values are closer to 0, right? Lastly, let's understand this with interaction and without interaction, right? So I'm choosing this. Let's come here, data analysis. See this with replication and without replication, right? It means this replication aspect is corresponds to the data set that you are using. Okay, is the sample size same across your groups? In all this, the number of samples for ascorbic acid and number of samples for orange juice, they are the same, no? 10. Number of samples for dose 1, dose 2, dose 3, they are the same. If they are not same, it means without replication. I can have a scenario, right, where the number of subjects for ascorbic acid and orange juice may differ. The number of samples for dose 1, dose 2, dose 3, number of subjects is a better word, no, instead of samples. I have 10 subjects on whom I give, on whom I administer vitamin C and see the results. The number of subjects is the same, no? Number of subjects is the same for ascorbic acid scenario as well as orange juice, and number of samples is the same for dose 1, dose 2 and dose 3. If for some reason it is not same, we use without replication, right? Do you understand? So this is what Anova is all about. Lastly, we use something called as F-test, right? Why this is called as F-test? It is named after a British mathematician, a very celebrated mathematician, Fisher, right? This is known as Fisher test or Fisher ratio, right? Or Fisher statistic. F value, F statistic, right? It is named after Fisher. Please note that what we are essentially studying is a means, but we are using variance. I mentioned this right at the beginning, right? I can as well study means, right? But I am not doing it. Why? Whenever I am saying I want to compare and contrast means, I am talking of difference, and difference is best understood by variance. I also want to highlight that it was Fisher who first introduced the concept of variance about 100 years back. So the Anova and F-test, all of these are about 100 years old, right? Before 100 years, in the 18th century or 17th century, the concept of Anova was not there. F-test was not there, right? See how much distance we have come, in industrial progress, this true industrial revolution, right? So Fisher played a big role. We are using the concept of variance in so many different aspects of our life, right? Machine learning is based on variance, to a great extent. In machine learning, we use the concept of variance a lot, directly and indirectly. So Fisher has indirectly contributed to the growth of machine learning, right? So we all should be thankful to mathematicians like Fisher, who introduced the concept of variance. Variance is nothing but standard deviation, right? It's another way of representing standard deviation. Okay, so that's what I wanted to cover in this video. Thank you.